you very much. I just gave it out off the cuff, unprepared and all that. Hopefully this will be better. Alright. So what is this all about is, today there's a lot of faith in penetration testing. A lot of people just do penetration testing for security. I have spent a lot of time in software quality, and I've seen those days when we know the code and threw it over the wall and let somebody else test it. We didn't really care whether the quality wasn't there or not. I'm trying to preach an approach where you should build security in. Because I believe that if you build security in, you will be more, the application will be more robust, and you will have use diversity. So this talk is all about how can you take an alternative approach to build security. Now if we look at how many of you do penetration testing? Oh, okay. Well, let me ask a different question. How many of you are in security, build their applications with security or for security or security is important? Okay, cool. That's more than one. Alright, so how many of you do penetration testing after you raise your hand? And do you do any other testing in terms of security as you go along? Well, this penetration is the only go along.
Yeah, we do. It's maybe not systematic,
Okay.
like you said.
Okay. Yeah. So penetration testing is from external perspective. It's from the perspective how a hacker, somebody who hacks the system, would hack your application. It's from external perspective. And what you are mainly doing is checking the periphery of your application. You are coming from outside and checking your application from outside periphery if it's good or not, secure or not. And in most cases, people are paying attention to OWASP top 10. Good place to start, very good place to start. But if you look at the effort, which is pretty much the next slide here, or challenges there are, the first one, if I'm a hacker, I don't sleep. My job is to hack, and that's all I do. On the other hand, when you're building an application, you have to use it at some point. So you don't have that infinite amount of time to keep on testing from hacker's perspective. You have to be more prudent or proactive to test from inside. Okay? The other thing is that there are a lot of cheap kits available out there. So if I'm a hacker, I can buy a lot of kits and hack all the time. But if you are trying to put a product out, you don't have that time. You don't have the luxury of time where you can test for everything. And that is why most people say, we're going to do OWASP top 10, and that would be good. And I don't blame them. But this is a way to get the product out of the door. You need to do that in a way that you're comfortable with it. Are you sure about it? That is something you cannot answer by just doing OWASP top 10.
Could you turn your lapel on, please? I don't think it's on right now. On the,
Yeah, I thought it was on.
I don't think so.
Oh, you're right. Thank you. Sorry about that. Okay, so now you can hear me. Should I repeat what I just said? All that I've said so far? Okay. Sorry about that. Okay, so now the focus here is that whenever you do penetration testing, you're looking at the periphery of the application, and you don't have the time a hacker will have to hack your application because you have to release a product. That was the gist of this slide. Okay, it's a little comparison between hacking and pen testing. Okay, hacking also is structured. Hacking is just not, oh, well, let me just do something. People try to see what's open, where they can go in, what's the back door, and they reconnaissance for some time. They think about where should I start, and they get their foot in, and then they go on and on to exploit more and more to the point where they can get something from your application. Okay, so it's in itself it's a long-term process. Okay? But the thing is that the hacker is not on a schedule, but you are on a schedule. Okay, again, the same point I'm trying to emphasize, that you are on a schedule and you have to release a product. Okay. What is the alternative? How can you follow a software development life cycle, and at the end we can say, yeah, we have a better product, we have a secure product, and we have some confidence in it. Because penetration testing, it only tells you, hey, we have tried whatever we can and we think we are secure. But if you build it from inside, you have a certain level of confidence. Okay? And if you look at security testing, it's a daunting task. Why is it daunting? Why is it a daunting task? First of all, you have all kinds of operating systems which were not designed to stand the hacks. How many of you trust Microsoft Windows for security? Probably not many. So there are operating system areas where you cannot trust the system. Okay? On top of it, you have some kind of platform, development platform, be it G2E or whatever you are trying to use. It has some oddities of its own. And then we also have open source. It's a good philosophy. If something is already there, why not use it? But how do you make sure that what's out there is secure? You don't know. So the whole process of building an application is so complex because all the things that are involved, and to make sure that we are secure is even more complex. So it's a daunting task to say, I have achieved the security I wanted to achieve. Now, from what I have read and what I have tried so far, I think the most important, the weakest link is access control. You can take a lot of things. This is where we really break down in terms of access control. Man-in-the-middle attack, stealing cookies, doing cross-site referencing, it's all access control type things. Okay? So I have a list of profound hacks that have happened, and the reason why I'm putting this together is it's just not one type of attack. There could be several types of attacks. There could be, if you look at this one, eBay was a totally social engineering attack. And if you target attack was a virus attack. I shouldn't say virus attack, but somebody installed a black POS on target operating system, point of sale system, and got the data. So there are so many types of attack that can occur, which makes things even more complicated. Yeah. So now let's come to the basics. What do you want to achieve? You want to achieve confidentiality, okay? You want to achieve integrity, and you want to achieve availability. That's your goal. The data should be kept confidential, and it should not be modified by anybody who is not authorized to modify it, and it should be available. We call it CIA. That's the goal. That's what I want to achieve. Now look at different three factors here. If you want it to be super confidential, put your application in the safe, lock the safe, it'll be confidential forever. But you just lost availability. Nobody can use it. So there is a balance of these three factors to achieve the right security you want to achieve. Yeah. I just put something, a little bit more details. When we talk about confidentiality, we want to maintain the data confidentiality both while the data is in storage and also in transit. until the data gets to the right client, we have to make sure that data is confidential. Now, there's things like, excuse me, there is intended malicious activity on the data. A hacker would do that. But there are times when your own people can make a mistake. That's unintended, because somebody just made a mistake and we lost the security. An example, a very simple example of that would be one of your salesperson had the laptop in the car and got stolen. They had no intention to lose the laptop, but it got stolen. So there could be intended and unintended. Integrity is all about authorized modification of the data, and availability, whatever time you define. It could be 24/7 by 365. It could be only for 2 hours. I want my data to be available for 2 hours. So availability is whatever time you define from your business perspective. Okay? And also, not all data needs to be protected. You have to be careful about, what do I encrypt? Do I have to encrypt everything that goes on the wire? Not necessarily. There may be some things we don't need to protect. So how do you really define, how do you assess what data needs to be protected? And if you want to know more about that, come to my workshop tomorrow. Okay, so these are the basic principles. I'm going to dig deeper into access control, confidentiality. And if you look at different aspects of confidentiality, first thing is, how do I identify that someone who wants to come to the system is the right person? Identification is the first thing. The second thing is authentication. I have to have some kind of proof or legitimacy. Okay? So first of all, I need to know the person is the right person. How do I prove that? That would be the next thing, and there's a couple more things after that. So identification is my user ID. Use whatever you want, your dog's name. A lot of times, actually, the trend has been, in a lot of cases, the user is your email address. Now, if you look at the email address, and I don't know how your company works, but the companies I worked for, it was always my first name dot last name and company.com. Now, I have done, when I needed to send an email to somebody, I could easily guess it. I know the first name, I know the last name, I know where they work for. So using email ID, I don't think that's the best or the most secure way of providing an ID. But it has been used for a long time. Now, I think that's the first thing we need to look at. Authentication, proof of legitimacy, something you know, like your special password, whatever you want to call it, something you know. It could also be something you have. There are times when we started working early remotely, we had a secure ID card. It was some kind of hardware. We generated a random number, and that becomes your code to go into the system. Okay? And then the last one is your physical characteristics. Finger scan is fairly popular nowadays, okay? But you can go beyond that. So when it comes to authentication, you should either know something, should have something, or your personal characteristic. That's how you want to identify what your proper authentication method is. Okay? Authorization, what are you allowed to access? What's your access privileges that you need to be maintained? And audit trail is important from the fact that, yeah, you always want to know who is coming to the system with bad intentions. But you also want to know who has come into the system with other intentions. So audit trail is always important to keep, not just to know who is a hacker who's coming into a system with bad intentions, but also to know who has come to the system. Okay? So those are the 4 factors which go into confidentiality. Now, what are the requirements? And this is where the approach changes. This is where we think about, we have a functionality that we need to put the requirements together for. So requirements, and I just listed here some very obvious requirements. Depending upon your system, depending upon your business needs, you can have more complex requirements. So all I'm saying here is, yes, some people should have an ID, and that ID should not be easy to guess. You don't want somebody's birthday as a password, or as ID, or some very basic thing reflecting the ID. And that's where I said the email is not the best way to identify people. If you can avoid that, that would be better. That is why we try to go into two-factor authentication system. Okay. Then some things like whether it's you shouldn't be able to share the ID in any way. Okay. I have been in situations where I wanted to add somebody to an application, like a quality center application. Being a lead, I will go to the support and say, hey, I want to add somebody. They would say, I will give you the privilege. You can add whoever you want. Well, that's not what I want. I just want to add somebody. And if you give me the privilege to add anybody, then you are really giving me more exercise than I should have. Okay. So there should be some check on that. You should never reflect the position or a role in a user ID. That would definitely cause social engineering problems. Okay. If I have an ID as Bhushan Gupta, CEO, or something like that, it's easy to know for a social engineering person, hey, this is the person I can have a social engineering attack on. Okay. CAPTCHA is not new anymore. This is just the way to find out if you are a human being or a robot. So this is a high level identification requirement. Okay. Like I said, they may be different for your company, but the first thing you want to do is, I have to support access control. To support access control, I need to have proper identification. To have that identification, what are my requirements? Okay. Any questions? Okay, so then comes to authentication. How do I know you are who you are? Again, the requirements based upon whatever method you choose to. You can choose a simple character string, and you can make it as complex as you want to. I was saying in my previous presentation that NIST is now coming up with at least 14 characters for your password. In those times of 6 or 8 or 4 are no more there. The one thing I'm highlighting here is also failure recovery process. If somebody forgets the password, if you remember a few years ago you forgot your password, and they'll give you the option to change it right away. And that's a very easy way to hack somebody's system. So now you need to have the requirements for password recovery, at least two-factor authentication. So that's the requirement. So what we're doing through this exercise here is, what are our requirements so that we make sure the system is secure. Same discussion again, authentication. There are situations, are there any requirements where I need to log somebody out? If the system has been idle, or somebody is not interacting with the application for, let's say, 15 minutes, should I shut it off? What do I do with that? So those requirements also have to be built into. What are the different ways I want to support authentication? Finger scan, I'm going to go with iris scan, I'm going to go with retina scan. You have to come up with all that. Okay. Let me skip that. We come to data integrity. There are requirements for data integrity, and I've listed few of them. There will be more according to business. Let me highlight a couple. This one is important. Your integrity of the data should be maintained, whether it's in storage or transit. So the database And we just had that discussion here. Your data in the database has to be encrypted. You cannot just leave it loose. And the data is moving over the wire. You want to make sure it's secure at that point too. That's why we go after SSL and high secure protocols. Okay? Who should access the data? Role-based access, always do that. Who needs to see that data based upon that? And if I want to highlight a couple more here, there should be a separation of duties to prevent fraud and errors. Any function that is subject to abuse. One of the good things, or one of the examples with that would be, if I am an administrator of a system and I want to do a user type work in the system, I shouldn't be able to do that from my administration access. I should log in again as a user and then do what I want to do. So that's the separation of duties. If you are, and then when you are an admin, you only have right to access the system with the admin password to do admin work. But when you want to do user work, you should change your login and then do your user work with the user password. It keeps track of at least if an authorized person accesses the right data or not. Okay. All right. So let's go on to availability. Redundancy is important. You got hacked is one part of it. How soon did you recover is another part of it. People judge you. People who do business with you will judge you on that. How soon can you recover? So redundancy becomes an important factor when it comes to availability. All right. So now we have gone over some requirements. Here's an example of what the security control should look like. Okay. So for example, if I want to maintain the confidentiality during transmission and at rest, I should have some kind of secure transmission protocol, strong encryption. HTTPS with the strong encryption. Okay. Data accuracy, data validation, both at client and server side. I need to make sure that that's my security control, and I should build it. I should check the data both at the client side. As a client, when I'm trying to use the application, I'm putting the data in. You should validate the data at that time, and also validate the data when the data needs to be written to the database. Okay. A lot of things, if you are familiar with command injection happens because we don't check the data. Let's see, what else can I highlight here? Recovery mechanisms are important. So this example, here's an example where every requirement you have, you need to have a security control. Now once you have that laid out, then you know what you are going to test your application for. And I think that's the rest of the presentation is on that. I threw this slide in just to give you an idea of what should be the secure design principles to make sure your application is secure. This is an example. Some major things here. We always believe in defense in depth, layered validation, okay? Fail safe. Okay? This is very important. Least privilege. Don't ever assign more than least privilege to anybody. If need be, somebody will come to you and will say, hey, I need a higher privilege. But always start with the lowest privilege. And that's how the systems are built. That's how operating systems were built. Okay? Now, there is a lot to be said about leveraging existing components. There's the third party, open source. Anytime you do that, you also have to make sure that those components you're using either have been validated to be secure or you have planned to validate them with your reference. So you have to have those security controls in place to make sure that you're testing all that. Right? If you look at top 10, OWASP top 10, and I have highlighted those here, Uh, One of the major things which you can stop, quite a few of these, is data validation, input validation. You can take care of a lot of things by doing input validation. Okay? And that's an important factor there. I have another one just to complete all 10 here, but my message would be, if you have good input validation, and if you have encryption on a secure line, you can avoid a lot of these things. Okay, so let's see how we would approach the testing. Okay. So we need to take multi-pronged approach here. Okay. And I have my ex-colleague here from a long time ago. We had a lot of faith in Fagan style inspections, because that's something you can do with a small amount of cost. So my prongs would be, I want to do reviews and inspections. I want to know what the design flaws there may be that I can catch, and you do these reviews on design and also on code. And they are, when you have compiled the code, then you can use static code analysis, the tools for that. You can use static code analysis. You don't have the object code yet, you have compiled code. And when you move from that stage, you move here, you do want to make sure that your system is properly hardened. What is a properly hardened system? An example of that would be that you have to take out all the default setup which came with the system. If you're using a tool, you may have some default set. Make sure you set them according to what you need, the system hardening. Okay? Because a lot of things come with default setup. Okay? And then you want to test the security while code is executing. That's when you do your OWASP top 10. That's when you use other tools which would run the code, and they will give you a list of vulnerabilities that you can take care of. Okay? So this is the approach I should take. I'm not saying do not do penetration testing. What I'm saying is that don't just do the penetration testing from outside. You have to build it from inside, given the requirements, given the security controls. Now how do I build the system, and then how do I test it? That's what I'm saying here. Okay? So we should take a multi-pronged approach. Fagan reviews needs to then develop an environment. You have to use, now there's a couple things here. There are processes and user rights. Processes have rights too. You may have a database, trying to get some data from the database, and there is a process using that database, some table somewhere. You make sure that even that process has proper rights. You do not want just any process to go and get the table, get the data from the user table. They probably would never need that. Okay. So that is the aspect, the process and user rights. Input validation. I just talked to you about SQL injection. Input validation is the key to stop that, and you can take care of that if you did reviews. It was fairly easy to do that. And then you can also check how the runtime environment is set up at this point, and that's system hardening. You can check that even before you go into running your system. So all that can be done through reviews. All right. There is some logistics here. This is kind of old process. I don't think I need to go through all this list here, but one of the requirements of inspection is you got to have experts, okay, in the areas you're looking at. So if you're reviewing, let's say, some aspect of database security, you have to have somebody who understands the database administration, what should be allowed, what should not be allowed. Okay, so that's one big part of Fagan style reviews. There are some pitfalls of it. I said here you need broad expertise, not just the database. You will have people from operating systems area. You should have people from language side area. So there are problems with languages too. So if you look at C and if you're writing your application in C, buffer overflow is a big problem. So you want to make sure that somebody is aware of that, or somebody is catching that. Static code analyzers, these are tools that you can buy. There is a couple of them. I have highlighted Veracode, HP. You can buy HP because I still have some stocks of HP, so the benefit from that. Okay. So there are some code analyzers. You're not running the code is compiled, and you go through those. You look at the warnings. Well, we used to do that when you guys programmed in your early languages. You always had compiler errors, right? And warnings. Errors you had to fix. You had no choice. But I mostly ignored our warnings. But you can't do that anymore because they may lead to some security problems. Okay. A lot of these tools also provide potential vulnerabilities for you. They will give you a list of potential vulnerabilities, and you can then go through and try to address those. And some of the tools, like I know Veracode here gives you a numeric index about how secure you are at this point. So knowing that how secure you are, or what's your security index, and knowing the log of potential vulnerabilities, you can go back and try to fix those even before you go for actual runtime analysis. Okay? There are some drawbacks with code analyzers. The big problem I have heard about is you get false positives. Okay? So which is, you need to be at least aware of the fact that there are false positives. And anything that requires resources, you got to have somebody to maintain the tool all the time. Okay? Dynamic code analyzer, these are again automated tools, and both the tools I highlighted here, Veracode and HP 45, they both do static and dynamic analyzer. And they basically simulate the vulnerability scenarios. Again, at the end, they give you an index. They quantify your vulnerability. They tell you this is how safe you are or how secure you are. Okay? You need to believe in that. You really want to believe that your system should be properly hardened. Don't leave your tools, your components, whatever components you're using, don't leave them with the default settings. Make sure that the settings you have are adequate for your business purpose, because you cannot depend upon that. I talked about login level before. Also, when you do, one of the things we need to do is proper configuration management. Versioning is very important too. When you are security prone, when you are hack prone, you want to make sure that you are up to date with all the systems you have. I specify here the default settings, and then principle of least privilege. I talked about that. And if there are features in your tool or third party component you're using, if you don't use them, turn them off, because they're not doing anything for you. Now those are the tools which were static code analysis and dynamic code analysis. But these tools here are scanning tools. The good thing about scanning tools is that you can use them and they will give you a basic map or basic idea about how secure your system is. And they will be at the very high level. You can tell you, hey, there is a SQL injection possibility here. They'll give you to that level where you can really identify what type of vulnerability there could be. Once you have that, once you have run your scanner, then you can plan the rest of your test planning, because you can pay more attention on the vulnerabilities that has been identified by a scanner. So you can balance your test plan. And based upon that, you can see how good are you with the release decision. Okay? So scanners are good. The one best scanner today is well, mostly used, I shouldn't say best, but is ZAP. ZAP attack proxy is free, doesn't cost you anything, easy to set up. If you want to know more about that, come to my workshop tomorrow, one in the afternoon. But this is ZAP is a fairly inexpensive, easy to learn tool, and it helps you, really benefits you with assessing where you are with your code at this point, and then plan your testing from that point on. It gives you a pre-assessment here. Okay. The scanners do a lot of things for you. They can do a sitemap, spidering, look for all the links, make sure they are working, being used or not. They can do scanning, and that's what gives you the vulnerability index. You can do fuzzing. Fuzzing is a process where you can throw a lot of parameters on your application, and then the tool will try to find out where the vulnerabilities are. Fuzzing is fairly widely used process. Port scanner, from a hacker's perspective, that's the first thing they look for. They will do a port scan. They will try to find an open port. If they find an open port, then they try to start hacking from there on. So it's important to have the status of all the ports that are open or working or non-working in your application. I have highlighted some strengths of the scanner. A lot of people use the scanners. Those who are in security and they want to have a quick check on how things are going, they use scanners because the investment is fairly low. Even if you go for a commercial scanner, which is Burp Suite, it's about $300, only $300. All right, so I just got the signal that I have 5 minutes, so I'm going to highlight the important things here. How do you really know the risk? Okay. In other words, if you have a vulnerability, how would you decide what level of vulnerability it is? And these are some techniques to do that. You will look at these categories. Okay, how much data is impacted? Can we reproduce it? How exploitable it is? And then, depending upon the answer to that, you assign a value. Okay? And once you have that, you can derive a severity value from that. And that would give you an idea. It's just like we classify our defects in normal way. You can classify your vulnerability like that. Okay? When you are doing a matrix for release decisions, what should you put in there? From security perspective, I think what you need to do is at least say what the total number of vulnerabilities are. Is there a baseline? If you have a baseline, compare your status against the baseline. What is the threat? What is the exposure? How much threat do you have? And then you got to have some way to respond to that threat. Risk containment, how well are the countermeasures put into place? If there was a breach, what would you do and how well can you execute those? Basic conclusions, I say it again, penetration is good. Keep penetration testing, but that's not the only way to make sure the system is secure. You got to take a multi-pronged approach. Use tools when you can. Some of them are cheap, some of them are easy to use, and they give you good value for your effort. Don't drop. Even though penetration testing from hacker's perspective, keep that in place. That is your final solution testing. Okay. All right. I think we have a couple minutes for questions. Oh, I did a good job, huh? All right. Okay, there are a couple of questions here. Go ahead.
So I wanted to know, what about security in non-production environments?
Security in
Right.
like
So, like I manage a group of folks who are testers.
Yeah.
And, so they need to have varying levels of access in order to test certain parts of the application. How closely should
Oh, I see what you mean. So if I'm a tester and if I'm going to test the login process, I should have access to that. Okay. If I'm going to test the database data manipulation, I should have access to that. So it's really depending upon what I'm testing. If I need to test if the data is secure over the line, I need to have access to that. So it's case by case basis. You have to evaluate all. And if all I'm doing is somebody is sending me a table and I need to verify that, then I don't need to have any high level access. There's another question back there. Yeah.
Do you think some of these activities should be written in contracts or better provided solutions?
Well, I think that's a whole new field. Okay. How do you, I personally don't think you can hold your vendor to how they build the solution. Because if you do that, you're really digging yourself deep into their culture. Okay. But what you can specify is we would only accept that number of vulnerabilities with that level. Okay. You can specify the security parameters. You can specify the security index. Something I didn't talk about here is attack surface analysis, which gives you an index. You can calculate an index, and that will tell you how vulnerable you are. And then you can say, okay, we don't want anything more than 15 ASI, and the ASI can vary from 0 to 69. Okay? So you can only specify the product qualities for a contract. Now, can you really, and even if you specify, do you build your system like that? Even if you have in the contract, how would you verify that? Unless they say, this is the day we're going to have the review and we want it to be there. Or you may ask them, did you review it? And when you reviewed it, what did you find out? Do you have a log of it? You can ask for those kind of things, but it's hard to really ask people to do things your way. I mean, you can ask, but would that happen really or not? So what is the outcome that you can verify? That should be the focus, I think. Yeah. And if they are certified at a certain level, which is not happening right now, there is no certification that you are a security level 4 or 5. It's not there yet. But you can also always ask, okay, how good is your processes? Right? It's a judgment call. Anything else?
Sir,
Yeah.
how do I identify those denial of service attacks, like from tester's perspective, like before even it goes to the security team for identifying that,
Identify.
like the denial of service attacks?
That's where DOS is not really executable unless you really run the code. Okay, DOS is one particular thing. However, somebody at the time when you are doing inspections, so DOS happens when you are sending a signal, receiving it, receiving it. Most DOS are caused by mismatch in. Can I keep talking? Okay. Mismatch in sending a signal to the client, to the browser, not the browser, to the platform, to server. Right. Thank you. To the server. And if there is something I can do just to keep send requests, and the server doesn't have time to respond to you, that's how DOS happens. So the only way you can see is that, so most of these tools are built in. People don't write code for that.
Right.
Okay? So it's very hard.
Many false positives as well in the database logs, the JPOS exceptions. When it was, we cannot identify anything as such because it was like just.
Yeah, right. Yeah, they wouldn't even know about it because it's a DOS. So how do you really, unless you execute that, this is very hard. And also the other question is that, can you execute in that lab? Probably not, because you have to really ping the server constantly. You may have a botnet or something to test that. So how do you really do that in a way that you hang the server? I mean, that's your goal. If you're testing for DOS, the goal is to hang the server, which means you keep on sending requests to the server, and then eventually it will hang. So the only way I think you can do it is by actually executing that particular test, and somebody, if you are writing the code, which people don't write for TLS, you don't write code for TLS because they're already there, somebody can review that at some point, which I doubt very much. So DOS is something you just have to do it.
Yeah, that's what has happened. Like for the whole day, the QA was down, and like the next day, you know, the
Yeah.
security team like they just restarted the server. But
Yeah,
as
yeah.
QA members, like we didn't have any,
The best way to do that is if you can simulate attacks or simulate requests onto the server, simulate that through some tool, then you can replicate that DOS attack. Anything else? Well, thank you very much, and those who sat for both the speeches, much more thanks to them.
Thanks, everyone.